Hello, my name is Javier Bendesu, and today I'll be presenting on Faraday's cage. We're going to talk about how these enclosures can make for great applications, and throughout this presentation, I will be able to link the applications to what I have learned in my electromagnetics course. More specifically, we're going to be diving into Gauss's law, and I'll be able to show you real-life examples of how a Faraday cage can protect people and electronics. So, what is a Faraday cage? A Faraday cage is an area made of conductive material that protects anything that is inside of it from electrical fields or electromagnetic waves. When an external field reaches the cage, the electrons that make up this material are going to rearrange themselves in such a way that the electric field within it is equal to zero. In other words, it cancels out. This is why anything we place inside of the cage, whether it's your cell phone or a person, is going to remain protected from any external outer electric field. How it works. When an electromagnetic wave or external electric field hits the outer surface of the cage, these free electrons are going to redistribute in such a way that it's going to oppose the applied field coming in. So this is where Gauss's law comes in, which states that the dot product of the surface integral of the electric flux density d in a very small patch of that surface in the normal direction ds will equal the charge enclosed. So if the enclosed charge is equal to zero, then the total electric field inside must also be zero, which is exactly what makes a Faraday cage work. Everyday examples. Now, even if we don't notice it, Faraday's cage show up a lot in our everyday lives. First, we have cars and airplanes. Both are made out of metal, and during a lightning strike, the current remains on the outer surface. This is going to protect the passengers and all of the electronics. Second, we have microwave ovens. The little doors on your microwave have a metal mesh, and this keeps the radiation from being emitted inside of your house. In other words, it keeps the microwave energy trapped inside of the microwave. And third, there are many buildings that accidentally act like a Faraday cage because of the way that it was built. This happens because the concrete walls have steel bars which are structured in a way like a cage. And so it blocks any external signal, and this is why sometimes you may find yourself without a phone service inside of an elevator or inside a very tall building. And finally, we have radio frequency blocking bags, which are also known as Faraday's bags. When you place your phone inside of it, it blocks any external wireless communication. This application is really good for law enforcement when collecting evidence because it allows the phone to be protected without any outer signal tampering with it. And here's that example of how buildings behave like a Faraday cage. Here we can see the steel grid, and when the concrete is poured, the metal forms a sort of cage-like structure that blocks any external signal. And another place where this shows up is in airplanes. The body also has a cage-like structure, and it's basically just like a giant Faraday cage flying throughout the sky. So, in conclusion, Faraday's cage is a good example of how this electromagnetic theory is applied to real life. The ability for the electric fields to cancel out on the inside comes from Gauss's law and from the way electrons rearrange themselves in a conductor. We interact with this complex but very fundamental concept every day without realizing it. Thank you for watching.